Okay, I want to share the screen. Mhm. So today I have something wonderful for you. Today I have a challenge. Okay, so
Okay.
we're gonna build some stuff. We're gonna work together. I'm gonna put you in different classrooms and different groups together, and you guys are gonna work together today. Okay, I think that we're gonna have time. We have time for this.
We will do in our account or
Yes, yes, yes.
okay.
Mm, mm. Remember, you have 750 hours for EC2s, and Amazon VPC is free. So you're gonna work on a VPC. You're gonna create auto scaling. Auto scaling is free too. But auto scaling, what it does is it launches, it launches or terminates instances, and you have 750 hours for a month. So you don't have to worry about that. You're not gonna be charged for anything. Okay. Okay, today we're gonna see Module 2, Section 3, AWS Core Services, and specifically we're gonna see Amazon Virtual Private Cloud. Okay, Amazon VPC. VPC is it's the most common way, people call it um, in AWS. Okay, so what's in this module? Part one, Amazon Virtual Private Cloud or VPC or Amazon VPC. Part two, Amazon VPC security groups. And part three, Amazon CloudFront. Okay, so we're gonna see these guys in. We're not gonna do anything with CloudFront because CloudFront is expensive. When you create a distribution with Amazon CloudFront, it's gonna cost us some money. So we're not gonna do anything with CloudFront. In the challenge, we're gonna focus on VPC and EC2. Okay. So discuss the key concepts related to the AWS Virtual Private Cloud, Amazon VPC, and security groups to better understand virtual networking in the cloud with Amazon VPC, creating virtual firewalls with security groups, and secure delivery of data, video, applications, and APIs with Amazon CloudFront. Okay. When we talk about delivery content globally, Amazon CloudFront is the guy. That's the guy that is used to deliver all the data and just what the users need worldwide. This is the guy, Amazon CloudFront. So let's start with the first part of this class today. So we have this Amazon VPC. Okay, it as you know, the AWS cloud offers space as you go and on-demand compute as well as managed services, and all are accessible via web. Okay? All of those services you can access them via web. So these compute resources and services must be accessible via normal IP protocols implemented with familiar network structures. So customers that need to abide with the rules and all the network structures that you create in your VPC, in your architecture. Okay, so all the users that use your resources, they have to go by whatever it is um, structure in this VPC or in the VPCs that you create. All right, so VPC gives you more security. Okay, so here we have several services here, the EC2 instance, and all the storage services that we saw yesterday. Um, Remember? And also, what happened now? And also the database services that we're gonna see. I think it is on Friday when we see databases. It's gonna be on Friday. And then we have here Amazon AWS IAM, Identity and Access Management. Okay, so Amazon VPC is a virtual private cloud, allows you to provision provision virtual networks hosted on the AWS cloud and dedicated to your AWS account. So, in other words, a VPC is a LAN in the cloud. Okay, it's a local area network in the cloud. That's what basically a VPC is. You know that you have, for example, you have one WAN that stands for wide area network. So that's the internet, right? So we can have a LAN, local area network, like for example, your network here in your house. So that's a small section. So what is the one? WAN is just a group of LANs together. Okay. So we have a VPC, it's like a LAN in the cloud, and then we have the internet, which is a group of VPCs together. Okay. So a private virtual network in the AWS cloud, Amazon VPCs are logically isolated from other virtual networks. So there are, isolated in a logical way to be more fault tolerance, okay? More fault tolerant. So one VPC has nothing to do with another VPC unless you establish some connection between them, a peering connection. But they have nothing to do with each other. They just connect them for them to interact with each other. But if one falls down, it's completely destroyed. The other one has, nothing will happen to it. They don't have, they are isolated. Okay. So many AWS resources such as Amazon Elastic Compute Cloud, Amazon EC2 instances are launched into an Amazon VPC. So whenever you create instances and AWS EC2 instances, whenever you create RDS instances, whenever you create auto scaling, elastic load balancers, all those guys, you can put CloudWatch inside the VPC. You have tons of services that integrate with Amazon VPC, and you can place them inside it. Okay, so it allows complete control of the network configuration, including internet protocols, IP address ranges. We create something called CIDR. It's a classless interdomain routing. So we can use that. You can restrict the amount of IP addresses that can be created in a VPC. You can even capture the IP addresses that access your resources, the ones that are allowed and the ones that are rejected. You can even see that. Enabling the VPC flow logs, and you can create subnets inside a VPC. You can create a route table. You can create a network gateway. You can create security groups. You can create so many things inside a VPC. And by doing that, you are having more control of all the configuration of your VPC. Okay, which is pretty good. The more control that you have, the better it is. Okay. I don't know if you guys like to give someone else the control of everything. I don't. So I feel more confident when I have the control of my own stuff. Okay. So I don't know. It may be a little lazy of me if I let someone else do my stuff. Sometimes we get so pampered and we let others to do what we're supposed to do, and then we feel so comfortable. Okay, I don't have to worry about that. But sometimes people fail, these systems fail, and sometimes people betray. It becomes a little difficult sometimes. So I prefer to have control. And when you have a VPC, you can have control of your own network configuration, which is pretty good. Okay. So deployment, when you deploy resources in the VPC, offers several layers of security controls. We spoke about security groups before. That's for EC2 instances. We spoke about NACLs before, the network access control lists. That's for the subnets. And we have flow logs for the VPC. So we have a lot of control. We have several layers of security in our VPC. So it gives you the ability to allow and deny specific internet and internal traffic. So with the EC2 instances, the security groups, we can restrict the access to our EC2 instances. Okay, I don't know if you watched the video that I created for the last load balancer that had two EC2 instances. Remember? And then you could have only one single point of entry. That video that I created. With that video, I was restricting the access to the EC2 only through the last load balancer, and that was done through the security groups of the instances. So I told the instances, you only allow traffic coming from the last load balancer. I don't want traffic from anyone else. So if someone tries to use the IP addresses of those EC2 instances, it won't be possible to access them. It's gonna be spinning and spinning and spinning, and it will time out in the end. Because
we did it in class.
Yeah, security groups only allow a specific traffic, right? But before you get to the EC2, before you get there, there's another guy that's gonna stop the traffic there. Is the NACL, okay? The NACL, the network access control list, that is at the subnet level, right? You're gonna have some rules there that deny or allow traffic, okay? Even before it gets to the EC2 instance. Okay, you have some layers of security that are pretty good, okay? So before it gets to the VPC, you can have some elastic load balancer. The elastic load balancer also has some logs. Also, there's one service, and I believe is in your exam. I don't know if you took the practice exam. There's one guy called CloudTrail. I don't know if you saw it in the exam. CloudTrail is the guy that's used to record every single API call. So whenever someone does something, if you delete, if you create, if you access the account, if you create a password, everything that you do in your AWS account, CloudTrail will record it. Everything, every single API call. So when it says API call, what it means is every interaction that you have with services in AWS in your account is gonna be registered, it's gonna be recorded by CloudTrail. So CloudTrail is the guy for governance, for compliance, for everything that will tell you what's going on. So when the person did it, where it did it, what he used, everything, it tells you, CloudTrail. So that's a lot of resources that can help you with security in your architecture. Okay, so other AWS service deploy into Amazon VPC service inherit security built into network. Whatever security configuration you have in your network, all the resources inside of that are going to inherit those security settings. Okay. So Amazon VPC integration. So we have here Amazon VPC integrates with all these guys. We have tons of services here. Okay. They integrate with them. Okay. It not necessarily they are inside the VPC, right? So integration doesn't mean inclusion, like it includes that. Okay, because Amazon S3 is right here. Okay. So S3 doesn't need a VPC. Okay. S3 can live outside the VPC. The same with Amazon DynamoDB. Okay. So these guys can be outside. You can access these guys without going to a VPC, into a VPC, right? If I go down to, if I give you a URL to my bucket, you can just type the URL or just paste it in your URL bar, search bar, and that's it. You get the resources from my bucket. Okay, so you don't need to go into a VPC for that. Okay, but this guy, Amazon EFS, we saw it on Monday. Remember, this guy, it's a network attached storage, so it needs to be mounted on a network interface. So this guy, it needs a VPC. So some of these guys are the ones that are integrated with cloud Amazon VPC. So you can see this later and take a look at that. I think that we're gonna see all of them. See most of them. We're not gonna see data pipeline. I don't think we're gonna see that. That's for the developer exam. Elastic Beanstalk, yes. Amazon Route 53, yes, we may see it. EMR, no, we're not gonna see Elastic MapReduce. Be careful with this guy. It may show in your exam, even if you don't see it um, in your class, right? So I think that, did I put it here? No, I have to include it in this group. Okay, so I strongly recommend coming to this section here and see what services you need to know about, because they're gonna be in your exam. Okay, not as the answer, which is a good thing, not as the answer, but one of the choices. Okay, so it's gonna show in your exam as one of the choices, but it's to confuse people. Right? It's not. You don't need to know about them. I mean, deeply, right? But they are there to confuse, test takers.
Is there any integration between the Amazon VPC and Amazon Lambda? Are they, can they be integrated? What would be the reasons why yes or why not?
No, Lambda is a serviceless service that doesn't need a VPC.
That doesn't need, okay.
Now, when you create a Lambda function, okay, you don't see anywhere any integration. Okay, let me see here, Lambda. So when you come to your Lambda functions, and then you create a function, right?
Mm-hmm.
You could create a function here and call it my function. Just give it a name you want. You have to create a role because Lambda needs a role to access other resources. It's going to create a basic role for me. Okay? And that's it. I created a function. So there's nothing else. So I don't have to put Lambda in any VPC. When you create a resource and during the process, you see some integration, you see that you have to put the resource inside a VPC, it's because that resource is a VPC-based resource.
So what level of security does Lambda has versus a VPC-based system?
Lambda is a fully managed service. So it means that AWS manages for you. It has everything.
I understand that, but what will be the level of security on this versus an AWS VPC based?
Okay, in the VPC you configure the security. Here you don't have to do anything. It's fully managed. It's all taken care of for you. Lambda has the highest level of security. Okay, but it's fully managed. You don't have to worry about it, right? And Lambda is just a function. Okay, Lambda is a function. It's not a resource like EC2 instance that has many features in place. Lambda is just a function. This is Lambda. That's it. So Lambda is a trigger. It's a trigger. It's triggered by events.
Mm-hmm.
Okay, it's an event trigger service.
Okay.
That it's outside your VPC.
Okay? So a traditional business, right, that is trying to move to the web, given the fact that that AWS is managing your security for you using Lambda, why would a company go with this, even though I mean,
Okay.
it's less resources because you don't have to worry about the back end, but why would you want to do that versus having a control over your your environment? More
Okay.
control.
Okay. This is serviceless. That's another different world. Okay. Serviceless. It doesn't need a server. And that's the huge advantage of Lambda. That you don't have to worry about any servers. Okay. So this is for serverless architectures. That's something that is growing in popularity right now. People are using serverless architectures more than ever. Okay. If you want to be in EC2, that's a server, and then you have to, comply with several standards because it's a server, right? Now, an EC2 is a VPC based service, and it needs to be configured in a way that it has security. Now, Lambda doesn't need security groups. Lambda doesn't need to be inside a VPC. Okay, Lambda is fully managed, completely managed by AWS. It has all the security. It has everything that it takes to be secure completely. Okay.
I understand that, but my question is
Okay.
from a business perspective, right?
Okay.
Why would you go with a Lambda implementation versus an implementation with a VPC? Is
Okay.
there any use case? What is the use case
Lam-
of one versus the other, right?
Lambda is faster than VPC. That's one of the use cases. Just in case you want to be faster, Lambda is serviceless. Okay, that's another use case. Maybe you don't want to go with servers. You want to go with without servers. You want to work without servers. Lambda is the guy. Lambda integrates with other serverless services like API Gateway, like DynamoDB. Okay, they form a great group all together to accomplish a serverless architecture. If you want to go serverless, Lambda is the guy for that. That's the main use case, serverless. Okay, so Lambda use cases. Okay, you see here using serverless. 10 reasons DevOps should use Lambdas. Most major languages are supported out of the box. Okay, that's one of the use cases, right? You only pay what you use. Okay, the same you do with EC2 instances.
Mm-hmm.
There's no infrastructure to manage. That's a good one, right? You have to manage your infrastructure with EC2 instances. Because, I mean, Amazon, AWS provides the resources, but you have to create the VPC. I mean, there's one VPC already created for you, the default one, but for production, it is not recommended. They recommend a custom VPC. So you have to create your VPC, you have to create your CIDRs, you have to create your subnets, all that. So you have to manage the infrastructure. Okay. You can edit directly online. So you can edit your lambdas. Once you create your VPC, you cannot edit it. You have to create another one. Okay. It connects to API Gateway. So that's another service for serviceless. It's the one that has to do with HTTP, HTTPS request, this guy, and other connection points. You can run Lambda locally. So you can run Lambda in your computer as well locally. And also Lambda are event driven. So you don't use EC2 with events. I mean, the only service, I would say, um, almost the only service that uses events for triggering is Lambda. EC2 doesn't have that. So when you take into account all these use cases, then you decide which one is more convenient for you. If you want to work with one that is completely triggered by events, so whatever happens, someone uploads a file in S3, someone, for example, deletes something. So any event that happens, Lambda will do an action. It will do an action, okay? Like, for example, stopping an instance or creating something, that's only everything created by events, okay? And of all these use cases, the one that is the heaviest is serviceless. Okay, you don't need a server. So people are slowly, slowly migrating to serviceless architectures. Okay, but you don't have to worry about the security of Lambda. It all happens behind the scene. Okay, AWS has all the security in place for Lambda, so you don't have to worry about that. It doesn't need a VPC. It doesn't need any configuration. It doesn't need any managing. You just upload the code and that's it. The code will run for you. Now, if you want to integrate Lambda with other services, then you have to make some configurations to integrate it with API Gateway, with DynamoDB, with X-Ray, which is another debugging service. So I think that's the main reasons why you go for Lambda instead of going for EC2. But it all depends. It all depends on, what do you want to do? If you don't want to go with serverless, then you go with EC2 and RDS, right? If you want to go with serverless, then you go with Lambda and you go with DynamoDB. Okay, it all depends. Or you can go with the EC2 and DynamoDB, but that's not a serverless architecture, right? Serverless means all of the services that you're using, all of them together, they all serverless. They don't need a server. Okay, that's serverless. It's fully serverless.
Can you go with an architecture that has a Lambda environment, right, with AWS, and connect to premises, server premises?
Yeah, you can do that too.
Is that possible? Okay.
Yeah, you can do that too. I mean, when it says serverless, it means that everything is serverless. An architecture, I'm talking about architecture, but you can have Lambda integrated with other services that are not serverless.
Okay.
Okay. But people are going for the fully serverless architecture. Everything is serverless. You don't need a server for anything. For API Gateway, you don't need a server. You don't need a server for X-Ray. You don't need a server for S3. You don't need a server for Lambda. You don't need a server for DynamoDB. So those are serverless services that are used for serverless architectures, right? And that's a huge advantage because many people don't wanna deal with the headaches that a servers brings, and they want to just forget about it and focus on something else, right?
Well, yeah, I mean, I see the advantages of serverless, right? But I also see the mentality of business where until now they have had control over their capital equipment, right? Their hardware, and everything that comes with that.
Okay.
So I'm trying to understand, more about the use case of this architecture in light of a person or a company, I should say, that has the traditional services,
Yeah. I think that's when your trust in AWS comes in. Okay.
Nah, in business there's no trust, my dear. I'm so sorry.
I have a question.
You have to come together with if I'm a business owner, you have to prove to me that your architecture is secure. So
exactly.
you have to give me data. You have to give me reasons why, and then I decide. Later, I decide, do I do serverless or do I do serviceful? So I have to decide, what do I do? Right?
Professor, I have a question.
Yeah.
I don't understand. I don't understand the idea of serverless, because then where's the information if there's no server?
Lambda doesn't need a server. When we create a Lambda function, do you see it? Do you see any servers?
Right.
Do we create any servers? It's just
it's a function.
Put the name, the role, and that's it. And selected the language. Because
so it's a function, not a server.
It's just a function. It's right here.
It's a function. Right.
It is. I think there has to be a server. It's just that we don't manage it, right? Serverless means we don't manage anything in it.
Right. There's always a server.
Got it. Okay, because I just didn't understand. Like, how could there be no server? Okay.
Okay, guys, my computer froze again.
Oh, brother.
God, I don't know why this is happening. I probably it has to do with Zoom or anything, or this live streaming thing with Zoom, the integration or something, because this doesn't happen to me ever, ever. But since I started streaming on Zoom live, this is happening.
You should, if you're paying for the service, you should call or put a ticket to Zoom.
Yeah, yeah, yeah. So we have to restart. I'll do it quickly, and I'll be back in just a few seconds. Right?
Okay. All right, so let's go get.
I'm going, get water.
Are we taking a break?
I mean, the dude's computer crashed, so he's
Oh,
gonna take a
crap.
second to come back.
All right, sorry, I wasn't here.
Now you're good, man.
Appreciate it though.
So I'm back here. So, like I was saying, Martina, there's no when you create a Lambda function, there's no server here to manage. Of course, every single information or every the data that remember, there's a lot of servers in a data center. Remember, it's like between 50,000 and 80,000 servers, right? in a data center. So it means that behind all this, there are servers working. But the idea of not managing with a server, not working with a server in your infrastructure, that makes it serviceless. Okay, that's what it means. Are you listening to me, guys? Can you hear me?
Yeah, well, we can hear you. I think she might have went to grab water because she thought you might take a second.
Okay. Okay. So here we have these guys that they integrate with VPC. So we have here a VPC builds upon high availability of AWS regions and availability zones, AZs. Each Amazon VPC lives in a single region. Okay. Multiple Amazon VPCs per account. I think you can have the limit. You can have 5 VPCs per account for new accounts. That's the limit. You can have up to 100 VPCs per account. Okay. But for new accounts, there's only a limit of 5. Right. So nets are used to divide Amazon VPCs. The main purpose of subnetting is segment your network and make it more, more organized. Okay. And it allows Amazon VPCs to span multiple AZs, right? The subnetting, right? Each Amazon VPC must specify the IPv4 address range by choosing a classless inter-domain routing CIDR block like 10.0.0.016. Now, there's one side, I think it's called CIDR dot. Let's see, CIDR X. This one, I think it's this one. CIDR. All right. So this guy helps you understand a little bit better how these IP addresses work. For example, if I have a CIDR of 10.0.0.0, and then the notation is 16, I can allocate 65,536 IP addresses. Okay, so I can create a VPC that has this CIDR. For example, if I come here and I come all the way down here, when it says networking and content delivery, and I have VPC here. Okay, so I have my VPC. Right now, I have my default one, right? I have my default one, which is the one that has CIDR 172.32.1.0.0/16. Okay, so we put that CIDR here. So say one, which one again? See again? 172.31.0.0/16. We can have up to 65,536 IP addresses between this range, this guy, and this guy. So you can have a lot of IP addresses. We can play with this two part here. You don't touch this, okay? Okay, this is the host and the network. So you work with these two guys, and then this combination here between this range here, we can have up to 65,536 IP addresses. Okay, so I can create my own VPC. Okay, and I'm gonna put my first VPC. Okay, and the site is gonna be 10.0.0.0/16. Okay, we saw this before. We saw that this guy will give you 65,536 IP addresses, right? So I can create my CIDR here. I can just select the IPv6 CIDR block provided by Amazon. Okay, because maybe I don't want to have some IPv6 there, or I can choose this. Okay, I can do it if I want to. The default of the tenancies, the tenancy, if it is default or dedicated, let's leave it default. That's the one that is by default. And then we create a VPC. As simple as that. You see? Right now we have a VPC. It's right here. Okay. And then we have the CIDR here. We have the tenancy. Okay. And the owner here is me. This is my account number. So we have all these guys here. Okay. And this is the default one. Now, okay, I cannot edit this. Right? I can add another one, but I cannot edit it. So we have to be careful when we create a VPC, right? We have to be careful because we have to be sure of what capacity we need, how many IP addresses we need, okay? Because we don't want to waste IP addresses, okay? Now we can create flow log, okay? And here, this is the one that will register all the IP addresses that are rejected or accepted into our network. Okay, we're gonna see all this with these flow logs. We can have logs here, and of course, when we have these logs, we can save them in an S3 bucket. Okay, so this is how easily you create a VPC, very easily. Okay. Yes, sir.
This Oscar. So you always have to create then 10.00.16.
No. It's just a standard. It's just a standard. If you need less, you can have -24.
Okay, yeah, but always 10.0.0.0, I guess, or not?
No, mira, you see the default here.
So, but then the point in which you mentioned, I mean, unless I understood incorrectly, you said at some point in time, you cannot modify this. You always have to create this.
That's right.
But I thought you were referring to 10.0.0. So again, don't worry. Maybe I misunderstood. So anyway, the IP range, you define the IP range based on the number of addresses you need.
Correct.
Okay.
And then you have to do the same for your subnets. Okay. But the subnets, they need to have this guy too. Okay. But the difference between the subnet is that a subnet cannot be the same as this one. It will have to be 10.0.01.0. Okay. So I have subnets here for my default VPC. You see here? Remember the default VPC had 172.31.0.0?
Yeah.
See? They have 172.31. You don't touch this, right? But you can play with this. You can play with this. Now here, you change the number here because they're different subnets, right? And then the slash is different. It's 20. So 20 is gonna get 4,096 IP addresses. Remember, AWS always takes 5 per subnet. Okay. I don't know if we spoke about this the first day of class, something like that.
I can't remember that.
I think I said it. I don't know if it was in the afternoon class, but for every subnet, AWS will take 1 and 5. I'm sorry, 5. So if we create here, let's say that create a subnet.
And another question: if the range is not defined, by Amazon, hence given to me kind of by a range pool, when I create a certain range, say I define 12.0.0.0 because I like that number, then if that range is taken, it will prompt me into no, I'm sorry, the IP address range is taken. So does it go to the table where all IP addresses are given, and then it checks, or how does it work?
By taking by who?
I mean, imagine I go now and I create now a different VPC with 172.31.0.0
in your account.
In my account.
Okay. Yes, they cannot overlap.
That's the point. So it will tell me the IP address is taken, basically.
Okay. It cannot overlap inside the VPC. If it is another VPC, it can be the same.
So with another VPC, it can be the same.
Yeah, because it's different VPCs. They're isolated from each other. Okay. Let me see here. Publish on net. Okay, publish on net 1. So I'm gonna have a CIDR here. I'm gonna put it inside my VPC, right? The one that I created. Okay. Let's see that I wanted to have it in my US East A1. Okay. And the CIDR for this one is gonna be 1.0.0 .0 and 24. Okay. So I create this one. Okay. So net has been created. So if I take a look at this one, you see, when you say that 24, that's 256, right? It took 5 already, right? Now I can create another public subnet. I'm a private subnet or a public subnet again. I can say public subnet 2. Okay, it's gonna be the same VPC. Now we're gonna put it another AP1, and then we're gonna say 10.0.0.0 at 24. This is not gonna work. It shouldn't work. You see, because they cannot overlap. So I have to put here 1. Okay, there it works. So right now I have 2 subnets here that are public. Okay, what I've done here, it doesn't make my subnet public. Okay, I haven't done anything to make my subnet public. What makes a subnet public? It's a question for you.
A connection to the internet gateway.
Correct. So in the route table of this subnet is right here. Okay, I need to already have a local one which allows traffic inside the VPC. I have to put another entry, edit a route table, and I have to put an entry that points to the internet gateway. So that's what makes this subnet public. Okay, so I have another subnet, private subnet 1, right? And I'm gonna put it inside the same VPC. I'm gonna put this inside this one, okay? And I'm gonna say 10.1.0. Do you think this is gonna work? No, it's not gonna work. So I have to put what? 2, okay? It cannot overlap, right? So now I have this, and if you take a look at this notation, it only allows 256 per subnet, okay? But like I said before, Amazon automatically takes 5 IP addresses from this guy, okay? I can create another private subnet.
Why, Professor? Why does Amazon take 5?
Because it needs 1 for the network, 1 for the router, 1 for broadcast, 1 for the future.
Got it.
Okay, it needs that. That's covered. I think I will cover later.
Okay.
See, and this was gonna be B. Okay, so here I have to put 3. Okay, 3, and then 24. Okay, so now I have 4 subnets here. Okay, 4 subnets here, and they Amazon took 5 subnets per subnet. I mean, it's 5 IP addresses per subnet, and they are inside the same VPC, all of them. Okay, so this is 2 availability zones, right? 1A, 1A, 1B, 1B. 2 availability zone. Each has a public subnet and a private subnet. Okay, so we have 2 availability zones that, this is highly available, right? Now, whenever we create an EC2 instance, right? If we create an EC2 instance round and we go to the third step, is the configuration.
Hey, this is Skylar. What's up? 441 Toyota. I am currently away from my desk.
Okay, who's, can you please mute your phone, please? So we create here VPC, an EC2 instance, and then here I can select my VPC, the custom one, the one that I created, and I can select my subnets here. So I can put this specific EC2.
Hey, this is Scout with 7440.
Hey Siri. Hey Siri. Call Southern 40. Hey Siri.
Hello. Hey.
Hey Siri.
Professor, you can mute him.
Sorry, I can't call it.
Yeah, I did already. Okay, so I can put this EC2 instance in my public subnet 1, right? That's availability East 1A. Okay, and then I can create my EC2 instance here, right? Inside that custom VPC and inside that public subnet. All right, so I can come here and check to see if the internet gateway is being created for me. So you see this internet gateway? That's the one that comes with the EC2. When you create your account, this is created for you automatically because it creates a VPC and it creates this automatically. So this is the ID, okay? So I can come here to the subnet and the public one, right? And the route table, I can edit the route table and I can add I think it's the, let me see. I think it's here. I think it's in the route table section, route table here. So we have this route table. And then my first VPC right here. I can have a route table here. I can edit the route, add a route here, destination. I can say this, okay? And then here, I can say internet gateway. Okay.
Don't you have to create a new internet gateway?
Not necessarily. It's already created for you. Let me see if I create a custom route table. Okay, so we have here my custom route table. And then the VPC here. Custom route table. There's the local one. So net association, okay. So I have to put here, I have to associate it with the public IP, the public one. Okay, the public one is here. Okay. So now it's associated here, right?
Is any of this going to be on the exam?
No, it's just giving you an idea.
This is on the afternoon class.
Okay. Okay, so the route table is already associated with.
You're in the right place. For some reason, it's not looking. It's not finding your internet gateway.
So I have to look into this. This guy here is associated with this with the custom route table. So what I have to do now is just create another route that goes to the internet gateway. Okay, so this is local, and oh, I know what's happening. I know what's happening. I have to create an internet gateway for that VPC.
Yeah.
Okay. Yes, I was thinking.
I did the lab. Okay.
Yeah. I was, okay. My new internet gateway. That's why it doesn't find it. I just my bad. Internet gateway. Okay. So now it's created and is detached.
Uh-huh.
I have to attach it to a VPC. A VPC is gonna be my VPC. I attach it. It's attached now. So I can come here to the subnet, the route tables, my custom route table, right? And then now I can add this.
Mm-hmm.
And then I can say here, let me see here. So internet gateway, this one.
Yeah.
And then 0 here, 0. And then save route. This is not okay. Okay.
Doesn't it have to be the subnet?
What? Okay, 1 moment. Okay, it's recognizing that it's when I do this, let me see the route table here. Edit route table.
Mm-hmm.
Okay, we don't have to do here. I don't have to do anything. So what it is done is here. Okay. So these guys are associated with the route table. Okay. So what I have to do is just, this is where it all happens here. This is where it all happens. I have to create this guy here. But so I have the internet gateway here. Okay. And this is what, okay. All right, let me see something here. One moment. Let me see something here.
Okay. So
Select the internet gateway. Internet gateway.
okay.
Internet gateway. Internet gateway is already created. Route table. Oh my God. My God. Yes. Oh my God. I don't know why I made that mistake. You see, now it's connected to the internet gateway. I don't know why it's putting 10. I know that this is for all IP addresses. All right. So right now it's connected to the internet gateway. Right now it is a public subnet. Okay. Right now that subnet is public. Okay. That subnet is public. Okay. You see, route table of this guy if you take a look at the route table, right here, is telling me that the route table is connected to the custom route table. And in the custom route table, there's an association with that subnet, and therefore there's an entry that points to the internet gateway. All right, that's what makes that subnet public. Okay. Is there any questions in the chat that I need to answer?
So, I mean, I just posted a comment or request.
Yeah, but this is important to know because you may have some questions that tell you what makes an IP address in the public subnet public.
Okay,
So,
I'm just a little concerned that there are more advanced people, you know, or more advanced people in, you know, on the call that will kind of shift the focus to the afternoon class versus the morning. I need to stay in the morning.
No. Even if I didn't have an afternoon class, I would do this.
Good. Okay.
That has nothing to do with the afternoon class. Nothing to do.
Okay.
So you have to create this address range cannot be changed after the Amazon VPC is created. Address range can be large as 16. This is the highest you can go, 16, which is 65,532. And this is the lowest you can go, the 16 addresses. All right, so you can say 10.0.0.0/28, but you have to know that it only accepts 16 IP addresses. Okay, so the lower the number, the more IP addresses you're gonna have. The higher the number, the less you're gonna have. Okay, so I have a question for you guys. All right, I have a question for you. If I go here, right, to my EC2 instance, I don't have anyone, okay? But if I create one, right? If I create one. So I come here. And when I get to a security group, I do this. Okay. And for example, I put a specific, let's say, a custom TCP, for example. And if I do this, let's say I want to come here and just put RDP, which is a remote desktop protocol. Okay. This is a Amazon Aurora RDP. Okay. So, and I put this. For example, 192.168.1.0.0.32. How many IP addresses do you think that I'm allowing into my EC2 instances?
None.
None?
What do you mean none?
Because there is only 4 available and Amazon takes 5.
No. This has nothing to do with the subnetting. This is an EC2 instance. This is for allowing traffic or restricting traffic to my EC2 instance. Okay. Here I'm allowing the IP address here using RDP, which is the remote desktop protocol. That's a protocol with this port. How many IP addresses am I allowing here?
Total 4, but you will be available 2. One go for network, one for broadcast.
Okay. No. This has nothing to do with subnetting.
32.
I'm not creating a CIDR. Okay. So if 16 allows 65,536 and 28 allows 16, how many do you think that 32 would allow?
None. I mean, it like 32 only allows one, but you don't even
Correct. And that one is
192.168.0.0.
Exactly. So I only allow this IP address, only this one, because I have decided 32, only this one to access my EC2 instance. No other EC2, no other IP address. Okay. So your exam, you may have something like this, like, this maybe 28, maybe 24, something like that. And you only want to allow this one. Okay. So the answer is the one that has 32. Okay. 32 means that only this address is allowed. Only that one. Okay. But if I say, for example, this, I means that what it means is that 65,536 in this range are allowed. Okay. In this range, all of them started with 192.168 and then all of them.
So this doesn't have anything to do, what you're doing right now doesn't have anything to do with the maximum and minimums that's it. With the maximum and minimums that AWS allows.
That's right.
For a VPC.
Correct. But what I put here is an example that 32 only accepts one. Okay? Because 16 is 65,536 and 28 is 16. Okay? This CIDR is not only limited to subnetting. Whenever you put 28, it means that in that range, I only have 16 addresses that are allowed to my EC2 instances. Only 16 addresses in this range. Okay, so this is very important for security groups to restrict access to your EC2 instance, just in case you see an exam, okay, or your practice exams. So addresses.
Professor, this might be a little confusing for people that have no background in.
Oh, it is. It is indeed super confusing. I mean,
I think well, not the point 32. I mean, not the 32. The 32 is very straightforward.
Yeah, no, I agree.
Well, wait a minute. There's some people in this class that do not have networking background, and might be confusing to them. So
okay, that's why the very first day of class, one of the requirements of any class in AWS, even including this one, you have to have at least a basic knowledge of networking, at least a basic knowledge. Okay? That's one of the requirements for by AWS.
I mean, I still remember, Dunieski, you saying that, even if you don't know anything about computing or anything about this, you will be able to get it without any problem.
Right.
Which that's okay. I mean, we're not going to get into that, discussion. That's okay. I mean, the fact of the matter is that, we're probably getting extremely technical in detail. And, our question, and probably some other folks as well in the call, is how can we make it a bit more digestive? You know what I mean? So a bit more easy to swallow. It is probably that.
Yeah. But this is you're gonna see this all the time, right? This all the time. Okay. What you need to know with this, not going into details, is that this guy will make this accept 65,536. So the higher the number, the smaller the number here, right? Up to 32. 32 is the last one. It's the smallest one, right? 32 is only one. So if you come here, if I say 32, it's only one count. It's only one. It means that the traffic will be allowed from this IP address only. Okay. Now, if you put 16, 65,000 for 28 is 16. Okay. You have to know that when you create your VPC, you have to allow space for IP addresses. But this is not only limited to VPC. This is only for security groups in your instances. Okay. Because this is a CIDR. A CIDR is a range. It's a range, right? When you scroll here, if you put 28, it's a range from 10.0.0.1 to 10.0.0.14. Okay, it's a range, right? Whenever you put this, there's always a range. That's going to happen for your security group. You have to know that when it comes to EC2 instances for the security groups, because you have to make your EC2 instances secure, right? And how do you make a secure instance secure? Through the security groups. And the security groups, unfortunately, work with CIDRs. Okay, that's something that you have to know for this exam, even if it looks advanced.
I mean, that's not hard to understand.
Yeah, yeah. So you don't have to go into the details how this work, how many octets, this, that for IP address, but you have to know that there's a CIDR and there's a range that has to be there for you to allow or restrict access to your EC2 instances. Right? You don't have to know that into details, but I'm just explaining to you because the more you know, the better it is for you. You don't even know what's going to be in the exam. I don't even know what's going to be in the exam, so you can maybe be surprised. So I always like to give my students more, a little bit more. They can be more equipped and more prepared, without going into the details because it's more complex. But when you do your lab, for this, if you did it already, okay, no problem. When you do lab, you're gonna do exactly the same that I show you. How to create a public IP, a public subnet, a private subnet, how to route that to the internet gateway. You're gonna do that. So it's not something that I'm just putting here to make it more complicated. You're gonna do it in your lab. Okay, so I think the lab, I think it's today, lab 2, but you're gonna see it. You're gonna see it. I'm just preparing you for that. All right, so netting segment of the Amazon VPC's IP addresses range, where you can launch AWS services. Subnets with a zone cannot span zone. Okay, they cannot overlap. One subnet equal one availability zone. All right. Something that I want to tell you before we continue is that my dear students, I'm not preparing you for an exam. I don't prepare my students for an exam. Okay, I prepare my students for an exam and beyond the exam. Okay, so whenever you find a job, try to find a job. They're not gonna ask you how many. I mean, they ask you something, but they may tell you create a VPC for me, or create an EC2 instance, or just configure this security group for me. I want this and this and this. How can you do it? Okay. So I wanna go and prepare you for that too. Because if my objective is to prepare you for an exam, I think that I'm falling short. That's my opinion, my own opinion. I'm falling short. Okay. And we don't do more things because we are here online. But if you're in a classroom with me, you're gonna create Lambda functions. You're gonna make everything work, even though it is not for the exam. Even though it's not for exam, because you never know what's gonna happen after when you finish this class. You don't know. You may find a job, you may have an interview, and then you may not know what to answer. Okay, so I'm just want to make that clear because I'm trying to help you. I'm not trying to confuse you or make you, panic or something. I just want to help you understand this and become better and better and better each day. Not just know the basic theory only. I want you to see it because when you see it, you understand it better. Right.
I do. I appreciate that, Professor. I really enjoy learning, which is why I'm here, and I like the in-depth, but my concern is because we have so little time that we go deeper and miss some of the basic stuff that's
we have plenty of time today. Today's PowerPoint is short. It's not long. We have plenty of time. We even have time to have a challenge.
Okay.
We're gonna have a challenge. All right, so subnetting, it can be classified as public, private, or VPN only. Okay, so you can have a VPN only subnet that's only for VPN connections, only for that. Okay, so far what we did was a public subnet and a private subnet. Okay, we create that. We create one in one availability zone, one in the other. Okay, default Amazon VPCs contain one public subnet in every availability zone within the region with the net mask of 20. Okay, so if we come here to the network of the VPC, the default one, the subnets for the default one, you have here a net max of 20. Okay, that's what they come. That's the default subnet. Okay? 20. which, like I said before, originally 4,096 IP addresses per subnet. That's a lot of IP addresses. Okay, route table used to control traffic going out of the subnets. We saw that already. Dynamic host configuration protocol, DHCP option sets, provides a standard for passing configuration information to host on a TCP IP network. Yeah, you know this dynamic host configuration protocol. It's when you assign IP addresses dynamically. Okay, security groups, a virtual stateful firewall. I don't know if you remember when we said in the first day of class, I think, that security groups are stateful. It means that whatever comes in comes out without any problem. So in a security group, when you create a subnet an EC2 instance, I want you to see it. You come here and you create an instance. And then when you create the security groups, you don't have to work on any outbound traffic. For example, if I come here to what it says security groups in the EC2 instance dashboard, I have here a security group. You see, by default, outbound rules, it says all traffic. Okay, so it means that whatever enters port 80 will come out. Okay, so whatever enters port 22, it will come out. Okay, that's what stateful means. Stateful means that whatever enters comes out. Okay, there's no tracking of state. I'm sorry, there's a tracking of state. Now, unlike security groups, NACLs are stateless. Okay, so don't forget that security groups are stateful. They keep track of the state, and NACLs are stateless. So whatever comes in doesn't necessarily go out. Okay.
What is
So,
stateful? Which one you said was stateful?
Security groups.
Okay.
And NACLs are stateless. Okay. So you need to know that for your exam. NACLs control access to subnets and are stateless. Okay. It's right here in the PowerPoint. Okay. So security groups are at the instance level, and NACLs are at the subnet level. Okay, 2 layers of security. Security groups are stateful, NACLs are stateless. Okay. So we have an optional Amazon VPC component. Internet gateway allows access to the internet from Amazon VPC, right? This is the one that allows traffic to the internet, to the outer world. Okay. Elastic IP addresses, right? They're static, okay? They don't change. Public IP address that can be pulled from the pool that use on a temporary basis. So if I come here, okay, I can create an elastic IP, right? Amazon is going to be pulled from the IPv4 address, and I can just allocate that, right? Now this guy is not associated to a yet. Okay, so I have to associate it with an elastic with an EC2 instance, right? So if I create an EC2 instance, I want to show you what happens when you create an EC2 instance and you stop it. All right, I'm just go through go through the process real quick because we don't need to stop on this. Okay, so tag security groups, review and launch. Okay, I don't care about anything else for now. Okay, so I'm gonna launch it. Okay, so it's been launched. Now it's pending. All right. So I want you to see this guy here. All right. Take a look at this guy. Okay. So I want to paste it here in the chat. Okay. So I'm going to paste this here. So right now we have this IP address, right? I'm going to stop the instance. I'm going to stop the instance. Stopping. So the instance stopped. I'm going to start the instance again. All right, and the instance now is starting. Can you see the chat window here? Can you guys see the chat? Okay, good. All right, I want you to take a look at this IP address and compare with this one. You see? Is it the same?
No.
No, it's not. So it means that every time that you stop an instance and you start the instance, you're going to get a different IP address, which is a little confusing, a little inconvenient for people that want to find our EC2 server using the IP address. Okay, so how do we resolve that? What we can do is go to the Elastic IP and associate this Elastic IP with an EC2 instance. Okay, so we're going to associate it with an EC2 instance, the one that is running, right? And we want to, we can allow this IP address to be reassociated with another EC2 instance in case this EC2 instance is eliminated, it will automatically associate it with another EC2 instance. For example, all the scaling groups, when they create a new instance, you can associate that with that EC2 instance. So right now, if I come to the EC2 that we just created, it's going to have this Elastic IP address. See here, the one that we just created. Now I want to copy this guy and I do exactly the same, right? And I'm going to put it here, right? And I'm going to stop this EC2 instance. Stopping again. Be careful with the Elastic IP address. It's only one is free. Okay, one is free as long as it is associated with a running instance. Okay. So now if it is, it's stopping here. Take some time. Well, in the meantime, we can continue here. So we have Elastic IP address, Elastic Network Interface, a virtual network interface. That what we used to remember yesterday when we spoke, not yesterday, Monday, when we spoke about EFS, Elastic File System, that we mounted the file system in a network interface. This is what is used for that. Okay? Endpoints, direct connections to another AWS service. We saw that already, how we can create endpoints for DynamoDB and S3. They are outside the VPC. So I stopped already. I'm gonna start it now, and then we can come back and compare the Elastic IP. So peering allows to Amazon VPCs to communicate. So just in case they ask you in the exam, how can you connect two VPCs? Well, the answer is VPC peering, okay? VPC peering. That's a process that I'm gonna teach you now because that's even more complex, how you connect to VPCs using VPC peering, okay? NAT address translations and NAT instance or NAT gateway. This is the one that is used for the resources in the private subnets to communicate with the internet, right? It accepts, translates, and forwards traffic within a private subnet. Okay, so you take a look here, it's already running. The instance is running. If you compare this IP address with the one that is here, it's the same. Right? It's the same. Nothing changed. So the solution to keep the same IP address when your instance stops or starts is an elastic IP address. That's the solution, okay? If you don't use an elastic IP address, you're gonna have a new one every time an EC2 instance is stopped, okay? Okay, so VPC connectivity, description, AWS hardware VPN, you can create an IPsec hardware VPN connection between your Amazon VPC and your remote network. Okay, this is something a little more advanced. VPN connections, don't forget that. If you want to connect your on-premises office with your network with AWS network, you have to use a VPN site-to-site connection. That's what you need to know, okay? And this guy, it needs the internet, okay? Direct Connect doesn't need the internet, right? That's another way to connect your on-premise network with your Amazon network. You can use Direct Connect. This one is more expensive. This one doesn't require the internet. It's through private links that Amazon has, okay? It's a very dedicated connection, okay? So 2 ways to do it. The most common ones to do it, VPN and Direct Connect. This one requires the internet. This one doesn't require the internet. We also have the AWS VPN.
So can I skip it? Bear with me a second. So on a typical, hybrid configuration where you have a certain, on-premise and a certain, VPC as well, let's imagine. Will you use Direct Connect or will you use, VPN?
It's your choice.
Your choice, it's a customer choice.
There's no specific, but this one uses fiber optic, okay?
Okay.
So see if you have that capability.
So will be more reliable and faster and so on, Direct Connect, I guess.
Yeah, this is more secure. This is more secure, right?
And more expensive.
And more expensive.
Yeah, hence more expensive. Yeah.
Yeah. All right. So we have APN Cloud Hub. You can create multiple AWS hardware VPN connections via your VPC to enable communication between various. Okay, so this is the guy that connects several. Okay, here you have one. You have several here, several VPN connections. Okay.
This answers a question that I've been asking myself. All these companies that provide VPN services, there's so many of them, and I say, how are these people doing this at this low cost? And this is the answer. Mm-hmm. They're able to provide those services probably by using cloud VPN services like this, like AWS.
And then you can have a software VPN connected to your EC2 instance. You can run software inside your EC2 instance. Remember, your EC2 instance is a server. You can install software inside your server. So you can create a VPN connection to your remote network by using an Amazon EC2 instance in your Amazon VPC that's running a software VPN appliance. So you can have several ways to connect to the AWS network, okay, from your on-premises. And of course, this is all for hybrid connectivity, hybrid connections, right? Now, Amazon VPCs can include resources in more than one availability zone, right? You can have multiple Amazon VPCs in the same account and region and in multiple regions or accounts, right? Now, Guys, I think it's time for the break. I'll give you 10 minutes break, and I will see you here 10:46.
Okay, let's go back.
Okay, guys, it's 10:46. We're back. Okay, so we have here in your screens, you see a region, right? There's a region that's US West 2, right? I think it's Ohio. I'm not sure. Ohio. I think
Oregon.
Ohio. Okay, so we're gonna build the VPC. That's we're gonna do that here. So the first slide, we're gonna create the VPC. So right here, you see the VPC. We're creating a VPC in this region, right? And then we're using it's a VPC for testing.
Sorry, Professor, are we following you on this or?
No. You just follow me just by watching. We're not gonna do anything in the console.
Okay. Thank you.
Slides. Okay. So we have a VPC for testing. Okay, you have a VPC for testing, a VPC for development, a VPC for production. And then we have the test VPC. So the CIDR is 16 notation. How many IP addresses can we allocate here?
Oh, 60 some. Was that no? Is that 65,000? Something like that.
556.
36.
36.
So we have 16,536 IP addresses that we can accommodate here. Okay. So next time we're gonna do some. We're gonna create a subnet A1, right? Subnet A1 is gonna have cited 24. 24. How many IP addresses per subnet? How many IP addresses here?
256.
Or actually 251. Don't forget that Amazon takes 5. Okay.
Yeah.
251 here. Don't forget that. Okay. Next, we create,
I have a quick question about that. Because remember before you said if there's a question on the exam. So if they have A251, B256, what's the right answer? A?
251. Because when you create a subnet with CIDR /24, that only allocates 256 IP addresses, but Amazon always takes 5. So it's going to be 251. Okay. Remember when we created the subnets in our the ones that I created?
Yeah.
You see, these are the ones that I created, right? And I put /24 right here. You see? So Amazon takes 5. Is 251 available?
Okay.
Okay.
Thanks.
Here is 4,096. Amazon takes 5 all the time for every single subnet that we create. Okay, so we have an availability zone here, and the subnet is inside that availability zone. When we create the subnet, we have to choose the availability zone. Okay, it's right here. We have to choose the availability zone. We put this inside an AZ, right? So we create another one, right? So can we tell if this one is public and this one is private? Can we tell that?
Yes, you can by the lock.
Are you sure?
By the lock? No?
Well, we're saying that the subnet is secure.
The lock is secure, but not private or public. Okay.
They're both secure because they have a knuckle, right? They're secure. But that doesn't mean that they're public or private. We have to have an internet gateway, right? That makes it public. Okay. So now this one is public. The lock is still there. Okay. So the lock doesn't mean that it's public or private. The lock means that it's secure, right? Secure. So this one is public, right? And this one is private. This is a very simple VPC configuration, all right? So outside we have the region, US West 2. Inside the region we have VPC, right? The VPC has the name is test, and the VPC has a CIDR of 10.0.00/16 that allocates 65,536 IP addresses, And inside the availability zone, there are two subnets. One is public and one is private. The public one, the name is public subnet A1, and the private name is public subnet B1. The CIDR for this one is the same as this one, right? The same CIDR. So each one allocates 251 IP addresses. Okay.
So what makes that subnet public or private? It's the connection to the internet gateway. Is that what you're saying?
Correct. That could be one of the questions in an interview. Very classic. What makes a public subnet public? It's not just the name. If I name it public, it's not, no, it's not the name. It's not the CIDR. It's not the knuckle. It's the connection to the internet gateway. What makes it public? There's no way in this world that this subnet would be accessed through the internet. Impossible. There's no connection. There's no routing table pointing to the internet gateway. Right? This is the one that is connected. Here was you put the NAT instance of the NAT gateway to connect to this one. Okay, that's for security purposes. Here I would place the databases, the applications that hold confidential information, you know, everything that is private that needs to be hidden from the public, I put it here. Right? Everything that doesn't matter if it is public, I put it here. Okay, so that's basically it. Security groups, we spoke about them before. The security groups act like a built-in firewall for your virtual servers. It's like a firewall, same as your computer, right? The security group rules determine who has access to your instances, and security groups are stateful. We saw that before. Stateful means that whatever comes in goes out, no problem, right? You don't have to worry about the outbound rules. Outbound rules allow traffic, all the traffic that comes in. Okay, and this is only for EC2 instances, don't forget that, and also RDS instances, but I'm talking about this is at the instance level. Right? So Amazon VPC security group, so we have here security group firewall for Amazon EC2 instances. So we have here the instances right here. We have the security groups here, right? And then we have the knuckles that work at a subnet level. Okay, so we have the traffic that's coming from the internet. It goes to this routing table, right? That has some routes, right? And then it comes to the knuckle. The knuckle allows or denies traffic. Then it comes to the EC2 instance and the security groups of the EC2 instances, and then it accesses the EC2 instance if it is allowed, right? So that's basically how it works. We have here two subnets, right? And we have two knuckles. And we have a routing table here. A routing table, okay? So it comes through here, right? And then
now this scenario here is a little different from the other one that you just presented.
Which one?
So in this case, the one that previous slides back that we were discussing.
Oh yes, yeah, because there were no knuckles or security groups in place. It's
so
just
in this
an overall, like a higher level overall explanation of a VPC without going to the details.
So in this scenario that you have right now, your subnets are, both of them are private, and they're only accessible through the knuckle. Either knuckle allows it, right? Through the routing table. Right. Is that correct?
Right. So once it comes in through the internet gateway, it doesn't mean that it's in. It means that it has to go through the knuckle, right? And the knuckle will allow or deny traffic. If it allows the traffic, it goes in the subnet, and then it comes to the security group. That's another layer of security. And the security group is gonna allow traffic. Okay.
So this is a more secure VPC configuration.
But actually, that's the way it is. That's the way it should be. Okay. What we saw before is just an overall like view. There's no here.
But you can still implement. But you can still implement this picture.
Yes. Is it that one is exactly the same? But they're just telling you about what is inside the subnet. Okay, and they're not displaying the knuckles here. Okay, there should be knuckles, right? That's why this is secure. But they don't show it here for you to have like an idea of the big picture. Okay, but when you go to the details, then you see this. Okay, that every security group, every instance, the instance cannot live without a security group. It has to have a security group and allow traffic. And then you have to have a knuckle in place for the subnet. Okay, you have to have that to make your network secure. Okay, and what makes this secure here is this lock here, is this guy here. Okay, and now you may have traffic that comes in the subnet, but it doesn't come in the instance. Okay, so the instance is the one that allows traffic into the security group is the one that allows traffic into the instance, and the knuckle is the one that allows traffic into the subnet. But the instance is inside the subnet, and still we have to go through another layer of security. So it's super secure, right? It's super secure. So don't forget that every subnet has a routing table. Okay. Every subnet should have a knuckle. Every subnet has information inside, servers and things like that, databases and all that. And they have a security group to allow traffic into the instances. Okay. Or denies the traffic, depending. Okay. Now the instance, don't forget that it has a key pair. Don't forget, it has a key pair and it's cryptography. Okay, it's encrypted. Remember, I think that if you take a look at my desktop, I think in my desktop. Okay. You see this guy here? That's the key pair. That's the key pair. That it has cryptography.
I have a question. I have a question for you. There is a PEM and a PPK. What is the difference between them?
PPK is for Windows. PEM is for Linux.
Ah, okay. Thank you for that.
Say that again, please.
Yes, when you download the key, if you're using Windows, you have to transform that. Let me put it here. This guy here, it says PEM, right? PEM. The extension is PEM. You cannot use this in Windows.
Got it.
So you have to change it to, you have to use PuTTY.
Oh yeah, that's so we did that. We did that. Yeah.
You have to use PuTTY and change it to PPK.
Yeah, we did that.
Okay. So, but it's the same key. It's just a matter of an operating system.
Right. Same key. Same key, different extension.
And the PEM is for which?
Linux. Linux or Linux-like systems like Mac OS.
So the Ubuntu will use the same thing?
Yes. Yeah,
okay.
That's Linux. Yeah. And Mac OS, if you have a Mac computer, yes, it does too. Because Mac OS is Linux-like, Unix-like.
Mac OS is what?
Unix-like. It's similar to Linux. Okay. So we have an AWS VPC security groups here. So we can access the EC2 instances using SSH port 22, or we can use RDP, remote desktop protocol. That's the port 3389. Okay, that's from your on-premises. So you can access your EC2 instances in AWS through on-premises using this guy too, RDP. Okay, and they have a security group here. They have a security group that is allowing traffic. So we access the web tier. The web tier is the web servers, the ones that are in the public subnet, right? So we access that using the internet gateway, right? The internet gateway. And it's coming either port 80 HTTP or port 443 HTTPS, okay? They're coming here, right? And then what happened here, you have to access this guy, the application tier security group, right? but the source, you can make the source of this only coming from the web tier. So you don't want anyone to come here and access this. In the security group, what you have to do is just the source of that. If you take a look at my video, if you watch my video on elastic load balancer and the EC2 instance, I use that. I changed the source of the traffic to the elastic load balancer. Okay, so the only way I can access this application tier is through port 22 coming from the web server, the web service. All right, it's right here. If you take a look at this, it says source web tier. The traffic coming from the web tier using SSH port 22 only. Okay, only that. Okay, now if I want to access the database, only we're coming to the database. The source is the application tier using port 1521. Now, the web server cannot access the database in this architecture. It cannot. It has to go through the application server, and the application server will access the database. So what allows this? Which is the one that allows this? The security group. So you can play with the security group, which is a firewall, a firewall that restricts or allows traffic to an EC2 instance. Okay, so you can use that. If you take a look at the security groups here, they have a source. Okay, they have a source, right? So traffic here coming through port 80 only comes from my elastic load balancer. Okay, I only allow traffic from my elastic load balancer. And SSH 422 can be from any computer, from any IP address. When you see 0.0.0.0/0, that's every IP in the world. Okay, so you can do that. Security groups is the one that specifies the source of the traffic. Okay, and the port range, if it is, you can say, you can do this if you want to. If you say custom, for example, you can say from port 80 to port 120. You can do that too. Okay, so you can specify a range, a specific port or a range. All right, so you can do that too. Security groups is good. They're good, and don't forget they're stateful. Whatever comes in, goes out. Don't forget that. Okay. Do you understand this traffic, guys? This graphic?
Yes.
Okay. So you can access this either through this port here from the office or through the internet. Okay, there are two ways to go into this architecture. All right, but there's security in place. Okay. Now review.
So sorry, could you go back? I have a question, Professor. Yes. So see the way the arrows are from the corporate network. So from the corporate network, you can access, because through the internet, you had to go through the web tier to the application tier to the database, right? Mm-hmm. From the corporate network, based on these arrows here, you can go directly to either one using the SSH or the RDP.
Right, and in that case, you have to specify the IP addresses of your network, of your corporate office. Okay. All right. So this is your architecture. This is your architecture. You can go straight to the source, right? Mm-hmm. But if it's coming from the internet, someone else, or the rest of the world, you have to go through.
Okay, thank you.
So we have a review here. We have this guy here. This guy. So we have the internet gateway, right? We come into the web server, right? Public have the NAT gateway, which is allowing this private subnet to. This is the same thing as we saw before, right? Same thing, but different graphic. Okay.
Did we do NAT? What's NAT?
NAT?
Yeah.
And NAT is a network address translator.
Oh.
This is what we use for the private subnet to communicate to the internet. So we put a NAT gateway or a NAT instance in the public IP and the public subnet. And through that, we can access the internet because the NAT gateway has a route pointing to the internet gateway. Okay? That's to make it even more secure, right? And highly available, very highly available. All right, so you can take a look at this, when you have some times. This one we are coming from from the office only. Why? Because this is a VPN only subnet. We install a software here, okay, that is allowing only the access through VPN. Okay, VPN only. VPC demo, we don't need to do that. The lab, I can explain it later. So we can go straight to CloudFront. Okay. So CloudFront is a global content delivery service, right? It's the one that is used around the world. Okay. If you want to be global and want to be, extremely highly available, this is the guy that's going to work with the entire world. Okay. And it uses edge locations, right? I think we spoke about this when we in the first day of class. Remember when we spoke about the points of presence and how many edge locations in the world? I think it was the 205 edge locations in the world, right?
Yeah.
And CloudFront works with that, right? Whenever users they want to access S3 bucket content, they go to S3, right? And then CloudFront, what it does is it caches that information in an edge location, right? And the next time when users grab that information, what's going to happen is that users will not have to go to the S3 bucket. They go to the cache location, the edge location. And the edge location is around the world, right? Let's say you live here in Asia. You have tons of edge locations here. Let's see that the S3 bucket was created in US 1, right? US East 1, right? They don't have to come all the way here to grab the information, right? CloudFront we get the information from the cache location, the edge location. Okay. So it's global growing content delivery network. It's expensive. Okay, it's expensive. You will have to create a distribution. I'm not going to create that now because I don't want to be charged money. And it would take like, I don't know, 16, 24 hours for the distribution to be created. It takes time, right? So you can create a web distribution or RTMP. Okay, this is more advanced, but this is the one that people use the most. Is the one that, you access your resources through HTTP or HTTPS, and you can make it really, really, really secure. Okay, so CloudFront is the guy for content delivery globally. Okay, for global content delivery. It's secure content at the edge location. That's what it uses to cache the information. Programmable content delivery network. You can schedule the delivery. You can have a TTL, a time to live, in the cache locations where the information can expire after some time. Right. It has low latency. It's high performing, because it has edge locations. High data transfer speeds. Is super fast. Cost effective. You pay for data transfer and request to deliver content to customers. No upfront or minimum commitment. So you just create the distribution and that's it, and begin using it. That's it. Simple.
Is this similar to Cloudflare? I think it's called.
Cloud what?
Cloudflare.
Cloudflare?
Cloudflare. No, that's not an Amazon service.
Okay, I don't know about the service. I don't know what it is. I have no idea. Like that? Cloudflare. Flare.
Like you, yeah.
It's an American web infrastructure and website security company providing content delivery network services. Yes, similar. Yes, this is what CloudFront does, and this is what CloudFront does too as well. Okay, CloudFront has this too.
So they're the competition.
Well, that's a company, right? This is a company.
Yeah, they're a lot of
Okay. Yeah, there might be a competition, but this is okay. Okay, I don't think I don't think you will compete with the AWS. That's I mean, you can compete with them, but there's a long way to get to catch them. All right. So we have a deep integration with all the services. It mostly works with S3, okay, and with Route 53 as well, and with elastic load balancers. All right, it works with all of that. So Amazon CloudFront,
Professor, sorry, what is Route 53? What is that?
Okay, Route 53 is it's a DNS service.
Okay.
It's a DNS service that has to do with you know routing requests around the world.
Got it.
This is a global service too.
Got it.
We haven't seen it here in this class.
That's okay. Got it. Okay.
But what it does is a DNS service. It's a domain name service.
No, I know what that is. Okay. Okay. All right. Thanks.
And then you can have a hosting zone there, and you can have A records and everything.
Okay. Good to know. Thank you.
You are charged by the traffic distribution. Pricing varies across your geographic regions. Don't forget we said that from the get-go, that regions have different prices, right? It all depends on the region. It's based on the edge location, how close it is, how far it is, all that. Requests, number of type of requests, HTTP, HTTPS, different types of requests. Geographic region too. Depending on the region, the request is going to be more expensive or cheaper, And always the data transfer out it's charged, okay? So, but there are different tiers depending on the amount of data transfer out of the Amazon CloudFront edge location, okay? So that's important to know. Traffic distribution, requests, data transfer out.
Mm-hmm.
You only charge for compute, storage, and data transfer out, okay? Those are the three things you are charged in AWS.
So Deneski, quick question. CloudFront, I guess, it's an optional service that, you can or cannot, install and request Amazon to be purchased. That's okay. So at what instances would you, go for CloudFront or not? Meaning, when is it imperative for you to choose, to get CloudFront? When you want better response from the web service because you are developing a web service here, say in Miami, and you have a lot of customers going from China. So from China into here, to have faster access, you would like to have CloudFront being accessible in the China region, or what is the scenario?
Yeah. Okay. First of all, you need to be a global company, right?
Yeah.
Not a local company. If you're a local company, CloudFront is not the guy. So you need to be global, right? You may want to be faster, right? You may want to give your users good experience, a very good experience. You can afford to pay for CloudFront, right? And you want your data to be highly available at all times at the global level, okay? So you would go for CloudFront, right? You may have AWS and never use Route 53 or never use CloudFront. You can do that too, but it's just this is like a luxury, like you're renting a hotel, right? You want to rent a hotel that is $39 a night, but then maybe you are hosting people that are very important, right? People that are that you will not rent a room on an inn in resident inn, right? You would probably go higher for a Trump, maybe a Trump hotel room or something like that.
God forbid.
Yeah, not Trump, please.
Yeah, okay.
But okay, yeah.
I'm talking about it's not the name.
No. It was a joke. It was a joke. It was a joke. Okay, go on.
It all depends on your company needs, how global you are. It's not some mandatory, but if you are at a company that's it's coping with a lot of traffic from around the world. That's very important, from around the world. And you have a big company with huge infrastructure and a lot of services and a lot of offices in the world, you might want to go for CloudFront. Okay, so this is a global delivery service, okay, and you want to do it real quick using edge locations. Okay, CloudFront it's widely used. It's widely used for many companies. But if you're local and you're a small company, don't even try CloudFront. You are going to be paying a lot of money that you don't need to pay for. You know, it's basically when you want to be really global, you know, global and have all these amazing resources at your hand and use them to ultimately give your users the best experience, okay, with content delivery. That's basically it, right? You may never use it, okay? You may never use it, okay? And you don't need to use it if you're a small company, okay? But it is there. It's there for you, just in case you need it.
So, Professor, it's for global reach and global distribution and faster.
Right, right.
Okay.
This is a global content delivery network. Right, so I think we are done with this PowerPoint. We explored the features of the Amazon Virtual Private Cloud, review of Amazon VPC security groups, and discuss Amazon CloudFront. Let me ask you questions. Do you remember when you took the exam, the practice exam, the ones that did? Remember that one of the questions was CloudFront?
Yeah.
Yes.
CloudFront is going to be your exam, right? And we just did a brief introduction, right? This exam doesn't go in depth about CloudFront. All right? It's just that it uses, basically what it uses is it uses edge locations. So they work together, okay? Edge locations and CloudFront, okay? Edge location, they're different locations in the world, very close to users, that cache the information, right, for a certain time. Okay, the information would expire, okay, after a certain time. All right, and you set the expiration date, right? You set it. You give it a time to live. Okay, when you see that the information is not being accessed frequently, then you don't use it anymore, right? It becomes stale. That's what they call it. It becomes stale, and then you disappear. All right, we're gonna have a challenge. If you don't have any other questions, we're gonna have a challenge. The challenge will take some thinking, but the challenge is gonna be in groups. Okay. So the challenge is the following, and the challenge is only intended for you to understand services better. Okay. So this is the challenge. We're gonna create 6 EC2 instances from the CLI. Right? 2 for dev, 2 for test, and 2 for prod. So how do you know the ones that are for dev? You have to use the tags, right? Tag it, right? Now from the CLI, you're gonna print all the EC2 instances. This would take a little research, okay? It's all there. The documentation is online, okay? And it's easy. And you're gonna be in teams, okay? You're not gonna be working alone. So you're gonna create 3 S3 buckets from the CLI, and you're gonna print all the buckets from the CLI. Okay? From the console, you're gonna create an auto-scaling group with minimum capacity of 3, desired capacity of 3, and maximum capacity of 5. Okay? From the CLI, you're gonna stop 2 of the instances created with the auto-scaling and see what happens. Okay? When you stop the instance, you have to grab the ID. Don't forget that, to stop the instance. Now for the CLI, you're gonna start the instances again and see what happens, okay? Now we're gonna, number 4, we're gonna create a classic elastic load balancer and register the 3 instances created with auto-scaling group. Okay? And make the classic load balancer the only point of entry to the EC2s, okay? So if you don't have time to do everything until 12, It doesn't matter. It doesn't matter. At least we start something. Okay. But I want to see you working with this. I'm going to be going to every single room and be there to see what you're discussing and what you're doing. Okay. All of this, we've seen it in class, right? We're not doing anything new, right? The only thing that may look new is the stop from the CLI and the start from the CLI. But if you look for that in the AWS documentation, it's going to be there very clear. Okay? How to stop an EC2 instance or how to start an EC2 instance from the CLI. It's very simple. Okay, so do you like it?
Can you put me on Brian or Maria's team? Because I don't know what to do.
Okay, let me see if I can do this automatically. One moment, because I don't want to, have any preference.
Wait, I don't know CLI well enough. I always
yeah.
go through the console.
No, I don't know.
The CLI is a challenge without being able to copy it from somewhere else.
Nice, but if you want to work in the cloud, you have to become CLI people. No choice.
No, wait, really? No.
Yes. You have to know how to use, that's the challenging part, right? Because the console is easy.
Yes.
So boring to having a console.
Ciara, you're going to be with Oscar. I think you're going to be, and John, you're going to be in good hands.
Okay, thank you.
Okay. So I have all the people here. I'm going to post the challenge on Slack. Okay. And then I'm going to open the rooms now.